and I'll toss it over to Tony to give her the chance to introduce herself too.
Hi, everyone. Tony Beekler from ESD 123, Pasco.
And hello, Tina, ESD 189 in Anacortes.
And thank you for emailing. Tina and Tony and I are sending out that email when issues have come up. Of course, today and last night is a big concern for many of our participants and many of our educators. So, sending good energy and vibes to them. But of course, if something comes up, thank you for emailing out. Our next opportunity is to, again, be in a space where we are welcoming the stranger into our space, to sit and learn from them, and to also acknowledge that you are the stranger to someone else, and your role is to be willing to contribute to that conversation and to do so with grace and gratitude. And we want to maintain that. It's been wonderful hearing from you guys and knowing that as we pop in to different breakout rooms that you are being very contributive to the conversation. So it's a thank you for doing that. Additionally, our work is focused on the definition of procedural fluency, and we've really been pushing on the expansion of what fluency is, from basic fact fluency to conceptual fluency to procedural fluency. And there are those three key vocabulary words, maybe a fourth, that fluency is accurate, is efficient, and is flexible. But I think I'm going to put flexible first. And finally, our 5 fundamentals of fact fluency: that mastery must focus on fluency. Fluency develops in 3 phases. Knowing foundational facts must precede derived facts. Time tests, they do not assess fluency, and that students need substantial and, most importantly, enjoyable practice. And with that in mind, that has been our framework that we've held onto as we've had our meetings. And I hope to continue to appreciate seeing those in our meetings today.
All right, everyone. This week, we're really looking at derived fact strategies. So we looked at doubling, which 2s, 4s, 6s, and 8s lend themselves well to doubling, adding a group, subtracting a group, as well as breaking apart and near squares, recognizing also that all of those are grounded in that breaking apart. And as we talk about teaching those derived strategies, we really want to think about that we use stories and visuals to help make those connections. We use stories and visuals to teach those. And let's look at a story. So we're going to look at some related division facts. The 3rd grade class is preparing coloring kits for a preschool. Each bag needs to have 5 crayons. How many bags can be filled if there are 45 crayons? So we're thinking about how can one of the strategies for division that was mentioned, and it's really the main research-based strategy, think multiplication, very similar to think addition when we're looking at subtraction. So how can we use think multiplication for this problem? A student might say, gosh, what number when multiplied by 5 could give me 45? And again, our students in the foundational facts have to have their 5s before we get to those derived strategies. Now let's take a look at another story. 3 children are sharing 18 crayons. How many will each child get? And the book talks really quickly about a strategy for division called close by facts. And some of you may know it as partial quotients. So what our students are doing is they're thinking about how close can I get to 18 with a multiplication fact that I know. And we know our students know 5. So they might say 3 children times 5 is 15. I know that. 18 minus 15, or thinking addition, 15 plus 3 is 18. That leaves me 3. Oh, I can go 1 more. So using those partial quotients or the close by facts can help us get to division through stories. And I will kick it over to Jeff, I believe, for helping making those connections visual.
Thank you, Tony. So in addition to the story and helping students make sense of the mathematics, we know that as visual learners, it's important for us to be able to see a representation and make connection, building our fluency through something that is visual. It's our nature, and our students succeed when they're able to do it as well. But it's about making those strategies visible. It's not equivalent that a representation is a strategy, but it's using a visual as a representation to support the strategy that we're developing in our students, some sort of derived fact strategy. Let's go ahead and take a look at this one. So my question to you, and you can either just mouth it off camera, but how many? Right? 36. How do you know it's 36? What is the strategy? And the book actually calls this out. So I'm going to give you a minute to think, see if you read it, and then I'll answer the question. What was the strategy the book called out? It's called near squares. Well, our kids need to know that square multiplication, the 6 times 6, 5 times 5, 4 times 4, gets them access to extended derived multiplication fact strategies. And so this is the strategy visually presented with near squares. And if we take this and we extend it to a related question, Tony's observation in the story component is also visible in our next, go ahead and go there, in our next question. How many do you have now for the multiplication 7 times 6? Right? So we know that it's 42, and we think about, or we want our students to use a fact about multiplication, the near squares strategy, that if they know 6 times 6 is 36, then 7 times 6 is one more group of 6 to be added on top of that squares fact they know. I guess I've kind of answered the question. How does A, 6 times 6, help you know B, 7 times 6? Give me a thumbs up or a thumb sideways if you are feeling confident in your students being able to use a squares fact in their multiplication. This leads us then to other representations. So the next one is using subtract a group. So just so I know, because I'm going to ask you to type something here in a second, let me know that your fingers are live. Go ahead and tell me the answer to the visual that you have on the screen. How many? When you got it, type it in chat. Okay. So we're able to visualize, thank you guys so much. We're able to visualize that each die has 3 dots on it and that there are 8 dies. So this visual is showing us 3 times 8. But if we know that fact, then with this arrangement, I guess our groups of equal groups, 7 equal groups of 3. Let's get there with subtract a group. How do we go from 3 times 8 to 3 times 7 through the path of subtract a group? Yeah, excellent. Thank you for responding in chat. Well done, right? So I know when I've asked this question of my own children, but of my students, a lot of the time that they go to additive thinking, it's always counting up. And it's a leap to teach them to go back, from additive add up and count up to, well, you already know a larger fact. Let's just take off the top. And we're going to see some more of these strategies as we continue to discuss and share out in our time today. Our next slide is actually going to also launch us into a Chatterfall question, but it's still the same question. It's the visual. And so right here in A, we have the math of 7 times 2. How many? Knowing our 7's facts is a challenge. 14, right? So what if we already know what 7 times 2 is, or our students know their times 2s, their doubles facts? Right? Doubling 7 and 7. How about this one? 7 times 4. That's the double. So when we talked about those basic facts for multiplication of knowing twos, fives, and tens, that's because this strategy was happening. That if you know twos, fives, and tens, then you can start now to double double a two and a two. Yes, I'm going to acknowledge, shout out, Kate. Thank you for that comment. We know our sevens because we can decompose seven into those fact families of fives and twos as well. Great observation. In fact, let's do that right now. Will you Chatterfart now? So I'm going to give you the countdown, 3, 2, 1. But the question that I want you to answer in chat is, what strategy was new to you? Or if no strategies were new, type in chat, what strategy were you glad to see while you read our chapter from this last week? The question from chapter 5 reading, what strategy was new to you? Or what strategy were you glad to see? Okay, 3, 2, 1. Press enter when you got it. And feel free to scroll through. Thank you. I appreciate what you're responding to, and we're ready to toss it over to Tina for the next part of our session. But I just want to acknowledge, that's where my own learning deficit grew from this chapter, is acknowledging a strategy that I kind of knew or knew that I could get to, and then actually calling it out in this chapter was that eye-opening moment for me. So thank you. Thank you for acknowledging near squares, decomposition, etc. Tina?
As near squares. So we're going to just take a foray into looking at our models, and we're excited for actually some of the other things they do, but we know we start off making arrays, and there's even like a game in the book about making arrays because that's actually a skill kiddos need to develop. Like, how do I draw things so that they're in groups of things, not just circles of things, but into an array, those rows and columns. So, but we love it because when kids start to do it, they can make sense of it. It's a tool they can use to help represent their thinking for a long time. And when they can get into the area model, this creates a really nice way to quickly generate a visual. And someone was saying in here, like, they really liked the decomposition. Wow, really visual with arrays and area models. But we want to say we love them being hands-on, but we can also represent them. And I want to encourage, as we go up the grades, 4, 5, 6, 12th grade, keep on using the visuals. Do not abandon them, because this idea that stems from arrays to area models grows up. We need to be using this in our middle grades and high school with for algebra. We use this to help develop quadratic formulas and also for calculus. So we need to not abandon this model and throw it away when we think they should be learning it all abstract. They should know this abstract. No, think about the work you could do with fractions and decimals with this. Keep using that model, that idea of the decomposition and multiplying pieces together. It doesn't go away. And we talked about this before, the language that we use, like, how would we say these two different? Like if you're doing like a fill the square, fill a rectangle space up. That's another great game. But the idea of the 1 by 6 and the 6 by 1, what is the difference? When we're just dealing with abstract numbers, sometimes we just don't, it may not, because we know we could do 1 times 6, 6 times 1, we get the same thing abstractly, may mean nothing at all. But contextually, it will make a difference, and it makes a difference when we can think about other mathematics that we do also growing up. And, shout out to high school, matrices have an order for their multiplication. And a 1 by 6 is not the same as 6 by 1. So knowing that, bringing situations out, because then kids can think, like, when we want to say near squares or break aparts, like, are we going to look at groups of something? So we need to know, and that's going to help us with quotative and partitive division as well. Like, are we talking about the group? Or are we talking about the how manys? So those ideas actually, we just wanted to take a quick moment to talk about that. And what we'd like to do is we want to open up rooms as a choice room today, just having a conversation with grade band ideas. Like, where are you in your understanding of the foundational and derived multiplication facts? What do you want to be talking to with a colleague? Talking about with your colleague. So we're going to have K2 rooms, 3-5 rooms. Then it's a combination middle school, high school. Choose where you want to go. So if you're a K2 teacher, choose that. We'll help you get to a room if you're not seeing where those come about. But I'm going to stop my share really quick. Remember, talking about multiplication, foundation, derived, what's going on, what are you thinking about? On your bottom board, on your Zoom menu, you'll either have a block. So I think the rooms are open now. You'll either see a choice or you have to press the 3 little dots for more.
Okay.
Look for breakout rooms, and that's where if you scroll on there, you can choose which room you want to join. Just so you know, we might move you if everybody goes to one room. It's hard to talk if there's too many people, or we don't want to leave anybody by themselves. So go ahead and choose a room. If you need a little help, unmute, let us know.
I'm trying to decide. This is Alberta.
Hi.
I'm trying to decide what room to go to since I have kids from all like at all grade levels except
Mhm.
the higher level.
Mhm.
So probably K through 5 or maybe K through 4 as far as their levels, but I teach
Okay.
the life skills class for the high school.
Okay.
So I'm trying to figure out where I would fit in because my students are so spread out with
Mhm.
their levels.
Let's put it this way. What if you wanted, because K2 will probably talk a little bit more about how this leads up from where they're
Guys,
at.
how do I get it?
So you might, why don't you pop in like a 3-5 room and just sort of see what they're talking about as far as developmental.
Okay.
Does that make sense? Okay.
Yes. I'll do the one with the least people in there.
That's awesome. Thank you.
Bye.
Everyone else, can we help you find a room? Do you need some help getting there?
Leave. Sorry, I'm getting assistance right
Hi,
now
Leah.
from my coworker.
Okay.
Sorry. More?
Okay. Christine, Lisa, Angel, can we get you somewhere?
Angel is the one helping her,
Angel's
so I
Oh, oh, hi.
can't figure out how to.
It's
help
not on
her.
my screen the same way.
No, it doesn't look like
I
mine.
think I'm across the hall, so Angel, will you come help me after?
So look for a little thing that says breakout. Looks like 4 squares, or you're going to click on the more button.
Oh, okay.
Or
You might need to click the more.
Join breakout room.
Can you just
Uh-huh.
Got
repeat
it.
that one more time?
There you go.
Okay. Thank you.
More button.
Sorry.
And then you click on the breakout rooms and it's going to
Okay.
say join breakout room, and just scroll down, and all you have to do is hit join on one of those.
Okay.
Do you see that now?
Yes.
Okay.
I'll just go to Angel's room.
Go ahead.
Okay, I'm gonna mute.
Christine, I lost track of who you might have been talking to. And I'm going to pop into the high school group real quick, okay? Or the middle school, high school.
Yeah, go ahead, Tina. I'm going to stay here just in case I need to
Okay.
move someone or,
Okay.
okay, thanks. Welcome back, everybody. Hope you had some good conversations.
Hello again. Thank you so much. I felt like I was able to jump around. I think Jeff was able to jump around. Out of curiosity, I heard some interesting things in a couple of rooms, but what is something you would like to share with the group about what you are processing with your grade level groups? You can put in chat or unmute.
Well, one of the things that we shared is that we wished we'd been taught this way. That would have been really wonderful. That sitting there with flashcards, at the dining room table was, it worked, but it was sort of semi-painful, And then the other thing that we mentioned was that how interesting it is to, instead of having the question, the story be after you've learned the formula, swapping it. Like, one of my colleagues in the class said, oh yeah, it's like they do that in science. Why don't we do that in math? You have this overarching question, it's like, oh, and so we just all thought that made a lot of sense.
So, like, that story makes more sense. And I'm going to take from your room too. You guys were talking about the multiply by 10 a near facts. If I know times 10, I can take a group away, and I got times 9. And I was just thinking, well, now your kids can multiply by 19, because multiplying by 19 sounds awful, doesn't it? But guess what? I could do multiply by 10, take away 1, and multiply by 10 again, or I can multiply by 20, take a group. I mean, really, really nice. So I took that away and was like, oh, that was really interesting. Anyone else real quick before I?
We talked about using words like decompose. In our science units, we're using the word decompose in terms of leaves and other things, but using that in math too. If they know what it is in one subject, using it again in math. And so just like how leaves and other debris breaks down, you can break apart these numbers too. And the kids really latch onto that. And so breaking it into smaller chunks totally works. So
Yeah, I love that connection to how we use language in different topics and within different subjects that help us understand the meaning. Lovely, lovely. Anything else? All right, well, I'm gonna mute.
We're going to get into our games section next. And in fact, Tina, don't go ahead and share screen. Go ahead and unshare, because we're going to go right into something to share with you guys. So our derived multiplication facts games, I thought it'd be kind of nice to see that these resources are supported from the Purple Book, which, has the 60+ games and assessments in there. But it's also got a link to the Kentucky Center for Math. And so the PDF of these games, I'm going to share with you. The game that we want to talk about is Strive to Derive. Give me a thumbs up if it's coming through kind of blurry, but you can at least catch up when I'm laying down. All right, thank you. So when you mentioned decomposition in our earlier visualizing things, this is the perfect game to help show that. And you can print this off of the Kentucky Center for Math site. It's mentioned as game number 33 in the book. And then if you need a recording for your own grade book or seeing what your students are demonstrating as their capabilities, this is there as well. But I went ahead and I printed out the arrays that go with them. And in this problem, let's just start with this one. the kids would go back and forth earning points, but also being able to practice their decomposition facts, their near doubles or their near squares or decomposition. This one, in fact, I see actually near squares because I see 3 times 3 and then 3 times 3 again. But maybe that's just the way that I saw it. And then I would go ahead and record it. And my partner would either acknowledge that I got the point, or there'd be some form of the game arrangement where they could steal it. They could also say, well, I saw it differently. I know that 3 times 5, because I know my 5's facts, is 15. And then if I use my divider, that's I think the fun part that makes it add to the manipulation part of it, that I have 3 times 5, and then I'm going to add another group of 3. So 18. Multiple strategies, right? Fluency means being flexible in the decisions we make towards making a fact, a math fact, become relevant. I got another one for you. Let's see. Let's try this one. How about, you see it, 12 times 3? If this is a great game for decomposition, then what might be the way that you decompose 12 times 3 to therefore know the answer? It's 36 to know that answer. Well, I know 3 times 10. So if I know 3 times 10, there's my divider. And then after that, I have 2 groups of 3 because 10 plus 2 makes 12. We're actually secretly practicing the distributive property that the kids are going to need to know later on in their algebra careers as well. So having them know that decomposition isn't just a skill for now, but it's also related to content later, or for our high school and middle school teachers, call back to it when you're trying to teach that algebra concept of the distributive property. Go back to a number visual representative that helps convey that property that kids are supposed to learn. So I would write that down. 3 times 10 is 30, and then there's another group, 2 groups, so that's 3 times 2, and then when I combine them, I have an answer of 36, and therefore my math question written in the array 12 times 3, and then I can re-express it this way. This is one of the games that we were able to highlight. There were a couple more, and we'll actually look at the Polypad when we go back to the real thing. We have the factor game, and we have 3 dice take, and these are great games that actually use all the operations because they're using multiplication, division, add, subtract, etc. So if you've gotten to the point in your practice with your students, they're building their derived fact knowledge for fluency, that 3 dice take and factor game are like, they're like the toppers, in my opinion, of getting students a chance to practice all 4 of our 4 operations and do it in a very fluent manner. I'm going to go ahead and stop share. Tina, would you bring us to the slide that has the Polypad links on it? So 3 dice take and the factor game, again, those are available from the Kentucky Center for Math, that are the add-on companion site for our Purple Book. And here in the Polypad, which we're going to have you go and explore in breakout groups, either the factor game or the 3 dice take, know that the magnifying lens will zoom so that you can see the instructions, but you can also locate the game. There's 3 dice take. You can locate it in the book. The way this works is you'll see 3 dice. And I guess I'm saying the rules while you could read them, but it's better to hear than read, right? Okay, so you roll the dice, and then those 3 numbers have to be operated on so that you can then claim a space. And if I see we had a roll here, a 3 and a 6 and a 3, I might do I'm gonna use distributive property here. I'm gonna kind of use a higher level strategy. Maybe I'm stealing your thinking, forgive me. I'm gonna do 6 plus 3 as a quantity, and then I'm gonna multiply by 3. So since 6 plus 3 makes 9, and then that quantity of 9, using my hands as gesturing parentheses here, that quantity of 9 multiplied by 3 makes 27. I would move a marker on my space for the 27 and then record on the recording sheet. For us in this space, it's side paper, but when you download the printable, your students could write it out, and that could be the thing that you collect. Then my partner, well, before I move on, there's no other spaces around the 27 that are marked, so I only get 1 point. But if I can use the dice to, let's pretend I got 26, if somehow able to combine my dice and get a 26, not only would I get a point for claiming the 26 space, but I'm also right next to 27, and 27 has been claimed. So that's 2 points, the bonus. So that adds to the choice as our students or us as we play this game are hunting for the most points possible. That we want to see if we could get, maybe I'm thinking strategically on the next time the dice is rolled when it's my turn. I hope I can get 18 or 19 or 34 or 35, because not only would I get that one square, I'd also get the other squares around it that have been covered. That's 3 dice take. Play until you've played, either time or the round, a certain number of rounds. Now, factor game, I spend all my time learning 3 dice take. So, Tina, can I get some help here on the factor game? What's the difference between this game and our 3 dice take game?
So in this one, you have to choose your spot first. Okay. So you can choose, like I said, you're going to choose a number on the game board. So if I get, let's see, I thought you were doing these, so I honestly
I know,
didn't review it. Sorry.
I'm sorry.
I was like, what did I do? Oh, okay. So here it goes. So I can choose, if I choose, say, 12, and I'm going to find all the factors of 12. So if I choose 12 on the game board, I get to take all the factors for that. So I get to take the 2 times 6, 2 times 6, 4 times 3. Oops, pardon me. Like I said, you can play on your own paper. And 1 times 12. And those get to be my score on that. So like the inclination, selecting and find the partner's factors, scoring their turn each round. Play continues until all the numbers are used up and the person with the highest score wins. So I get to take all of these points for that. And so then the next player goes and chooses a number. So you start to learn things like, oh, I might not choose 11 because all the factors of 11 are 1 times 11 and 1 is taken. But you're practicing factors, which is helping with division. It's going to help with fractions. It's going to finding all the factors of the game. So this is a game about factors, not about multiplying numbers, but knowing what the numbers are that multiply to that product. So like I said, you can play on the boards. We create it virtually so you can play in this virtual space, but obviously in person with little chips is going to be easier, or a little made board, and you can use erasable markers on it. All those things work. So I think we're just going to put you in groups of pairs, just kind of talk about this and what you could do. How would you change this up? What might be your first starts to get it started to play so that it can work into a rotation? And I do believe Tony's got us in those breakouts.
And thank you for this, Abe, Tina. I appreciate it.
Mhm.
You didn't know I appreciate you.
Welcome back, everyone. Well, almost welcome back. I'm a couple seconds ahead of myself here.
Oh, that was short.
Do you ever make silly faces into the camera and then realize that there's like 30 people watching?
That was my engagement strategy during COVID, just to see who would give me something back.
You put a clown nose on, a red clown nose one day. Wouldn't that be fun? People are way too serious.
Yeah.
Thank you, Leslie, for that transition. It was
Oh, the
perfect.
least I can do, truly.
Yep, it's like you were planning with us. All right, welcome back, everybody. So we looked at stories and visuals this morning to help us teach those derived fact strategies. We just came from practicing some games. Now we're going to look at how do we assess students' understanding and mastery of the facts and the strategies that they're using. All right, we are going to look at Graham Fletcher's daughter, and she's using multiplication subitizing cards to think about and solve some multiplication facts. So go ahead and just listen.
42.
How did you get 42?
I made 12s with all these, but this one in the center didn't have a partner, and all the ones that did have a partner equaled 36, and I added 36 plus 6 to get to 42. 24. 14.
All right, real quick, what do we know about her level of fluency from what we heard? Was she fluent, and is she fluent? Thinking about the definition of fluent when she looked at 6 times 7. Just a quick drop in the chat real quick. What do we know about her level of fluency? Those cards are great.
There's a link for those cards in the slide deck.
Awesome. Thanks, Tina. It's like had some strategies, not quite fluent yet, but knew to come back to what she did know. She knew 6 doubled, 6 times 6, or she knew the near squares. She has the strategies, but she's not there yet. Thank you. So just thinking about the opportunities that students can engage and narrate their thinking. To be able to do this, though, they need practice. So thank you for continuing to add in the chat, scroll through, look at those. And remember, as we're giving our students opportunities to practice, help them learn how to narrate their thinking. And that helps you, again, assess where they're at. Now let's look at an assessment tool. We are going to look at tool 21, which is on page 146 in your purple book. And that's the student record, the multiplication mastery and the multiplication fluency record. Notice not all multiplication facts are assessed. We're assessing enough to know if our students are efficient, flexible, accurate, and can choose an appropriate strategy. So we're going to give you an opportunity to take a look at that tool and jump into a breakout room of your choice and just talk about what did you notice about the facts that are listed there under the assessment tool? How does this tool help you, or how could it help you assess for fluency? What might you be listening for? Or what are some other big takeaways from chapter 5? So we're going to let you choose a breakout room real quickly, take a couple of minutes, and then we'll come back and wrap up. Yeah, it looks like Tina has the rooms ready for us. Thanks, Tina.
Yep. So again, it's a choice of rooms, K2, 3, 5, or high school.